Hello everyone, welcome to my presentation on visualizing hypothesis testing. My name is James Auma. The agenda is as follows. We are going to differentiate between null and alternate hypotheses. We are going to transform data visualization into presentations. We are also going to look at the important takeaway message. Our visualization number 1, we are looking at the test for a mean. On the y-axis, we have probability of defects. On the x-axis, we are looking at the number of defective widgets out of 100. The research question is, on average, are the widgets from Acme Widget Company defect-free? The null hypothesis is there is no relationship between the probability of widget defects and the number of defective widgets produced. The alternate hypothesis is our visualization number 1. We are looking at the test for a mean. On the y-axis, we have the probability of defect. On the x-axis, we have the number of defective widgets out of 100. The research question is, on average, are the widgets from Acme Widget Company defect-free? The null hypothesis states there is no relationship between the probability of widget defects and the number of defective widgets produced. The alternate hypothesis states there is a relationship between the probability of widget defects and the number of defective widgets produced. On our visualization number 2, we are comparing two groups. On the y-axis, we have the number of home runs. On the x-axis, we have the fraction of teams that are home run hitters. The blue curve represents the league, the red curve represents the minors. The research question is, does the average major league team have more home run hitters than its corresponding minor league team? The null hypothesis states there is no relationship between the number of home runs and the fraction of teams that are home run hitters. The alternate hypothesis states there is a relationship between the number of home runs and fraction of teams that are home run hitters. Our visualization number 3, we are looking at the efficiency comparison. The blue curve represents a single queue with single servers in sequence. The red curve represents a single queue with multiple servers in sequence. The red curve we are looking at 10 hours, at the blue curve we are looking at 4 hours. These are the number of hours observed, checked against the number served per hour. The research question is, the efficiency curves of the red and the blue teams were recorded. Do the teams have equal mean efficiencies? The null hypothesis states as follows. There is no relationship between the number of hours observed and the number served per hour by the red and the blue teams. The alternative hypothesis states there is a relationship between the number of hours observed and the number served per hour by the red and the blue teams. Our visualization number 4, we are looking at correlational test. On the curve, the y-axis represents the weight in pounds and the x-axis represents the miles US per gallon. A German study tested how larger industrial use vans utilize gasoline. One of their analyses plotted mile per gallon versus the weight of the various vans in the study. After plotting the data on a scatter plot, the researchers performed a correlational test and found a significant correlation. However, they forgot to state the hypothesis test in the published paper. The important question is, what are the study's null and alternative hypotheses? The null hypothesis in this case is stating that there is no correlation between the weight of the vans and the miles per gallon of utilized gasoline. The alternative hypothesis states there is a correlation between the weight of the vans and the miles per gallon of gasoline utilized. In our visualization number 4, we are looking at correlational test. On the graph, the y-axis represents the weight per 1,000 pounds, while the x-axis represents the miles per US gallon. A German study tested how large industrial use vans utilize gasoline. One of the analyses plotted mile per gallon MPG versus the weight of the various vans in the study. After plotting the data on a scatter plot, the researchers performed a correlational test and found a significant correlation. However, they forgot to state the hypothesis test in their published paper. The important question is, what were the study's null and alternative hypotheses? We state the null hypothesis as follows. There is no correlation between the weight of the vans and the miles per gallon of gasoline utilized. The alternative hypothesis states there is a correlation between the weight of the vans and the miles per gallon of the gasoline utilized. The important takeaway messages are as follows. In creating hypothesis tests, define the problem clearly. Validate the problem with a quantitative or qualitative data. You can set the hypothesis using words or equations. And again, in using visualizations, a curve or a plot of the data can hint at a possible hypothesis test. The curve anatomy, if bell-shaped and fairly symmetric about the highest point, then the highest point is the mean. Are there any questions? Thank you for watching.